Okay, I'm going to show you how to run a notebook on the cloud from my repository, assuming it's been set up with Binder. Here's my GitHub page. If you Google rsignal and GitHub, you'll end up here. Under repositories here is all my repositories, and here's one that I've set up with Binder called Binder Books, notebooks that run on Binder. And so the notebooks are up here. If you click this Launch Binder button here, it actually will launch an environment that will support running these notebooks on the cloud. And actually, if it comes up looking like this with just a URL at the top, refresh your browser. And I'm in Chrome here, so I'll do a Control F5, and that seems to be a little sticking point somehow. But anyway, so now I hit it Control F5. I see my notebooks here running in the Jupyter notebook. And so the way you would run one of these is you click it and then wait for the page to appear. And this is my notebook that will plot data from the hindcasts models, which are the New England Coastal Ocean Forecast System models. Actually, it'll plot models from any FECOM model that's in a compliant format. And there's actually down here in this cell here, there's a number of different models. And what I've got selected here is the 30-year hindcast monthly average here. These are comments, so if you wanted to select another model like the forecast model here from Mass Bay, I could put a pound sign in front of this, and you can see that it then kind of turned it off there. The color changed, and I could uncomment this one, and now you see that that one's turned red. So this would be accessing data from the Mass Bay forecast model, but I want to access data here from this 30-year hindcast model, so I'm going to go back and uncomment that one. Okay, so this is a notebook that it shows you actually the result of the last time it was run here. So each cell contains some code and then some output from that cell, and at the end there's actually a plot that's coming from this plotting up some data that I've selected from the model. So I think I'm just going to go ahead actually and run this. I go up to here to cell at the top, and then I go down to run all. And actually, just before I do that, you note this is number 2 here. It's the number of processing steps. So this should increase. This just keeps increasing as you run more cells. So it's the number of it's the order that the cells were run in. So if I say run all, you see actually this little dot turns solid up here, which means that it's running. If it turns empty and is white, that means that it stopped running somewhere, and then you would have to scroll up and see what happened. But you can see now it's still running, and it's processed a few of these. These have turned from, when I say run all these turned into star because they're waiting to run. But this one has a number 5, and now that you can see this is number 6 and now number 7. So it's actually computing all these different things. And we'll get to what those things are actually doing in a second. But we can see it's progressed through here. All these have turned from stars to numbers. This is still waiting to turn from a star to a number. And now this has actually gone through and plotted some warning messages, but that's fine. It's just some messages from the plotting package. And now you can see this plot of surface currents in Mass Bay. And what we're actually looking at here is what we've requested up at the top here, which is, first of all, as we've already mentioned, we're actually getting data for these 30-year monthly hindcast averages for the month. So these are average currents for each month. And we open up that file here and look at the variables in the file. We don't really have to pay too much attention to that and any of this stuff actually in here. But the things you might want to change are down in here. We're selecting different areas to look at. So you can look at anywhere in the Gulf of Maine, but so here's a little cell that would look at Woods Hole. Here's a cell that would look at Boston Harbor, and here's a cell, and it's just minimum and latitude, longitude, and minimum and maximum latitude, how big you want the velocity vectors to be, and how you want to plot the bathymetry, what kind of contours you want. So the last one, so I keep overwriting. You see this levels, and then levels equals this, levels equal this, levels equals this. I keep overwriting that with different values. And so this last one takes precedent, which is the Cape Cod Bay one, and that's why we're seeing Cape Cod Bay at the bottom. So I'm requesting from minus 80 meters to 5 meters in increments of 5 meters. So that's why you see the bands down here at the bottom. You can see every 5 meters is being plotted there for the bathymetry. And here we have the range. So minimum, again, minimum longitude, maximum longitude, minimum latitude, maximum latitude. So you could go to Google Earth and pick off some corners for some new area and type them in here. And then the velocity scaling here, and whether you want to subsample the data. I'm going for the full resolution here, which is subsample equals 1. If you subsample equals 3, you'd see less velocity vectors on this plot here. But why not look at them all if we're zoomed in? If you zoomed out, you'd probably want to change that to 3 or 5 or something like that. For instance, this one here in Boston Harbor, I've actually set to 3. If we want to see what Boston Harbor looks like, we can actually just go to the cell and actually move the cell down so that it's below Cape Cod Bay. So we can go down here, and now Boston Harbor will take precedent if we run these cells. I can click in this cell, go up and say cell run all below, and then it'll just go ahead and plot up data for you, because you can see here for a part of Boston Harbor that we had selected in. You can see there's fewer arrows. Okay, so again, we can change this to something else. Let's move it back to Cape Cod Bay. So we'll click here, move this back down so it's below. So it's the last one. So again, it will be it'll pick up these values. The program will pick up these values for Cape Cod Bay specification. The other thing we can change is up here, we could say that what time we want to look at. So right now I'm saying, again, we're sort of overwriting the start date, and it's using this last one, which is June 1st, 1992. So it's actually looking at June 1992, the surface currents for June 1992. And if we commented that out, or moved this one down to the bottom, now it would be August 1st, 1992. And if I commented that one out, it would be July 1st, 1992. And I just wanted to point out, you can also specify if you switched it to a forecast model and switched this to commented those out so they don't overwrite, did something like this, and said, so this is saying right now, UTC now, so it's saying right now, and this is saying like hours minus 1, so 1 hour before now. So you're asking for, you'd be asking for the forecast currents 1 hour before now. Let's actually just do that. So we'll go back up here and switch this from this forecast model to, say, the high resolution model for Mass Bay, and then we'll go down and we'll move. Let's move Boston Harbor back down to the bottom, because Boston Harbor is a little more interesting here. So we'll move that down here, and then we'll go up here and say cell run all. Okay, so actually we did need to say cell run all, because we're actually asking for data from the forecast model. Now you can see that it printed out the day here. So April 19th, 11 o'clock, that's GMT. So that's why it's different than the local time, but it is 1 hour before now. And if we go down to the bottom here, now we can see all these, the Mass Bay's model is much more resolved. You can see all these different vectors in Boston Harbor. And in fact, now you can see that the scaling is way off for Boston Harbor, and we might want to reduce that so that we can see those arrows better. I guess that's one more thing we might want to do. So we might want to go here and change this max vel to something like 1.0. And actually I can hit shift return here just to execute a few cells too. That executes each cell. So now we're going to see what it looks like. And it looks like, did I go the wrong way? I guess maybe I went the wrong way. Let's see what that looks like. Okay. Well, anyway, so that's kind of what this is how this works, and so you can feel free to play around with this yourself and get a feeling for get a feeling for how the currents look from the forecast models or from the climate data that's been run for the last 30 years or so. All right, thanks.